So first, I guess I'll do a quick introduction of myself and our team and talk about why we are offering this workshop. So I am on the data science team at Stanford. We're kind of split between Stanford Healthcare and Stanford University. Priya is my manager. If you've done other stuff with STARR, you've probably interacted with her and not me. I just joined in June, but I have really been enjoying having Google BigQuery available to me to work with our data. Like it just has so many cool features and it makes like poking around and exploring and trying different stuff really easy and smooth once you are used to it and kind of know how it operates. So I would really like to be able to bring other people along to that state and have other people also enjoy the different things that you can do with Google BigQuery. It's a really great way to navigate all of the different data sets, tables, variables, everything that makes up the database that we're going to be talking about today. So if you've been to any of the other workshops in this summit, this little series, this is the fourth one, and the other workshops focus primarily on pre-made tools that have been constructed to be used on the same data set, the STARR-OMOP data. But there's like an extra layer there in between you, the user, and the data. And that has advantages and disadvantages, right? Like it's going to somewhat constrain the different things you can do, but it's also going to make it a lot easier to do complicated things quickly if what you're doing fits well with what the tool was designed for. So this workshop kind of takes a different tactic, and we're really going to look at delving into the data itself to give you some more options for different things that you can do if it's not something that's already part of one of the tools that exist, or if you want to sort of augment what you have already done with those tools and add on more information. This can be a really nice way to do that as well. They definitely work together, so we wouldn't recommend doing like only one or only the other. We want you to be able to work with the data and the tools. And this is actually pretty unique. So I didn't know this until recently, but apparently most sites that have a STARR-OMOP database don't give other users of their sites direct access to the data. So we want you to be able to take advantage of the fact that we do offer that here at Stanford. Please feel free to jump in at any time with questions, and I'll try to pause sort of at different intervals as I go through. So part one is STARR-OMOP, and even this is going to be split into two parts a little bit. So we're going to start with what is OMOP. This will be pretty quick since I think most people have at least a little bit of familiarity here. OMOP stands for Observational Medical Outcomes Partnership, which was a partnership that actually doesn't really exist anymore, but it was what originally created this data model, this common data model. It is now maintained by Odyssey, which is the Observational Health Data Science and Informatics group. And that's a collaboration of a lot of people from a lot of different companies and institutions that are working together to improve observational health data research. We typically use OMOP as a shorthand to refer to a database that is set up according to the OMOP common data model format. So if you hear us refer just to, Stanford's OMOP, like that's what we're talking about. But this is where the term comes from. And basically it's just a set of instructions of like, these are all the tables you should have. These are all the things that should be in them, both in terms of variables and like the kinds of health data that should be included in those tables. Because EHR data, the electronic health record data from like the patient facing side is huge and contains a lot of information. So the common data model specifies how to transform that level of data into something that's useful for research in kind of an organized way. Cool. So what is STARR-OMOP? That is Stanford's internal version of the common data model. So that's our data coming from Stanford, from both the adult and children's hospital. And it has been transformed by our team in the data engineering team that we work closely with to be in this format that was specified by OMOP and by Odyssey. So we have the source data coming from our site, and it's in this format that is specified externally. We have some different aspects of this compared to other sites. So we do have a version of this data set that is refreshed weekly that is available to researchers. So it's pretty up to date. And then we have some features that are specific to Stanford OMOP. So like additional variables or additional information that aren't required by the broader organization. And that includes flow sheet data, which is included in the observation table. We'll touch on that later. but the flow sheet data is included as JSON strings, so it's like pretty free form. It's a little difficult to process sometimes, but it is all included, which is unique. We also have zip code information, ZCTAs, and that's can be obscured a little bit if the zip code doesn't contain very many people, but if the zip code contains over 20,000 people total, not just at Stanford, then we have the 5-digit zip code available, which is really helpful for different kinds of geographical studies and linking to other kinds of variables that are available. And then we also have insurance mapping. So what type of insurance different patients have. It's Medicare or private insurance and so on. So those are the things that are unique to Stanford's OMOP instance. And then we have all the usual stuff that is required by the common data model. Priya's dropping a lot of links in the chat that are related to this. So if you want more information, feel free to follow up there, and we'll also have resources linked in the slides that we'll send out later. So I mentioned that there's a version of this that is refreshed weekly. We create different sort of levels of detail for this, or levels of specificity depending on the confidentiality or the privacy restrictions for different data sets. So we have our full version of the OMOP, which is called STARR-OMOP CDM5. That stands for Common Data Model version 5 point something. And then the date that the data cut was taken from the electronic health record system. So if that's all it says, then that means that this is a fully identified data set. So all of the original information is there, the original dates, addresses, patient IDs, like free form notes, everything like that is in the full version that we produce. Then we have varying levels of sort of abstraction away from that. So the first one is a de-identified data set, and that means a variety of things, but mostly we're trying to obscure information that could be used to identify a particular patient. So the first level of doing that is jittering the dates, which means shifting them by a small amount, less than 30 days in either direction. And that amount is consistent across a single patient. So if we shift a patient's visit date by 5 days forward, we shift everything for that patient 5 days forward so that it's still consistent internally for that patient. But it's harder for someone to try to put that together with like real world information about when someone had a particular procedure or something like that. So that's one part of de-identification, is jittering the dates. We also sometimes just remove information fully. So things like address variables, like specific addresses, like the line 1 of an address, the street address, those are just set to null. So you don't get any information about that in the de-identified data sets. The notes, which are again, like free text notes that can be entered about the patient, those are tricky to de-identify because we don't know what's in them, right? They're not structured. And so we use a particular approach that's called hiding in plain sight. So we replace names and addresses and locations and things like that with substitute names and addresses and locations, rather than just like trying to like cross them out or something like that. And the reason for this is that if we miss some, you can't tell, right? So if you see a name in the notes when it's been passed through this algorithm, you don't know if that's the original name that the algorithm missed or if it's been replaced by a randomly chosen name. So I'm not going to talk about this in too much detail. It's not the focus of today's presentation, but just so you're aware that like there are various levels of this de-identification process, and they are designed to make the data still like useful from research purposes, just like the date jittering being consistent across a single person. So yeah, so that's the first level of de-identification. And then we go to DID Lite, which just completely removes the notes, like the unstructured fields in the data, rather than using this hiding in plain sight algorithm. We just get rid of it. And then the DID 1% Lite is a 1% random sample of this de-identified Lite data set. And it's 1% random sample of the patients that are in that data, and then all of the information for that patient is included. So it's not like a 1% random sample of each table, because then you would be able to link across tables effectively. So 1% random sample of the patients, all the data for those patients is included in this data set. And that's what we're going to be working with today. So that's a good one to be familiar with. So it's a lot smaller, obviously, than the full data set. It's roughly representative, like it's a random sample. It's not just the first however many patients that have ever gone to Stanford for care. But it might, like if you're trying to study rare conditions and things like that, this might not be a great choice because we might not see it in this random 1% sample. Any questions on this? Okay. So next I want to talk more about the CDM, which is the Common Data Model. I mentioned it briefly earlier, but we'll get into some more details of what that actually looks like for OMOP. So it is a person-centric relational database, sort of the high-level description of what the Common Data Model is. And there's requirements on both the structure and the contents of those tables. So structure-wise, we have a bunch of different tables that are specified. There's 16 clinical event tables. So those are things like conditions and procedures and drugs. There's 10 vocabulary tables, which don't contain any like patient information. They're sort of the structure that we use to talk about the different clinical information that's represented in OMOP. So those are a very different kind of table. No patient information, just connecting different terms that come up in the clinical tables. There's also 4 health system data tables, 2 health economics data tables, 2 metadata tables. So there's a lot of other stuff like infrastructure surrounding those clinical tables, but those really are the bulk of the patient information. And they are separated by the contents of the table. So for example, diagnoses or other conditions go in the condition occurrence table, lab results go in the measurement table, and so on. And as part of the CDM, we also specify how those pieces of information should be represented, which for OMOP is in the form of concept IDs. And we will talk more about that later because it is important to understand to be able to use STARR-OMOP, but it's, I guess, not immediately obvious what those stand for. So there is pretty good documentation. It's very detailed about these different tables and the variables in them at this link, which I've included below, and we'll be going through that in just a second. First, we are going to talk a little bit more about relational databases. So for some of you, this might be very familiar, but if you're coming from the clinical side, maybe it's, I don't know, less comfortable. A relational database is just a collection of tables, each with their own data, but that can be linked together using specific variables that will match across the different tables. So we call those linking variables keys. And we have 2 different kinds of keys that we use to talk about here. We have a primary key, which is a unique identifier for that specific table. So it's a primary key for a given table. It wouldn't be the primary key if you go look at another table in the database. Then we have a foreign key or multiple foreign keys, which are a way to link the observation in our main table that we're looking at to other tables in the database. So a foreign key on one table is likely to be a primary key on a different table. It's specific to the table that we're talking about, but these are the ways that we take a bunch of data, store it in separate tables, but are still able to bring it all back together to do whatever kind of research or studies we need using all of the data across the tables. So in OMOP, the primary key is typically a single column. That doesn't have to be true in general, but in OMOP, it's basically always true. And that column is named like whatever the topic of the table is _ID. So there's a person table that contains all of the patients that are in the database, and the primary key for the person table is called person_ID. So pretty easy to pick out, plus there's the documentation. And then the foreign keys will have a similar format, but they are like appearing on a different table. So for the person table, for example, person ID is our primary key, but then we have another column called location ID, which is the foreign key to the location table. So that's going to allow us to link a particular person to a particular home address for that patient. And the data documentation is very explicit about the primary and foreign keys. So I think Priya dropped the link to the documentation in the chat. If you can go ahead and navigate to that, I'll go to it as well, but I think it's useful for you guys to bring it up too. And we're going to play around with the documentation for a little bit. So we have the description of all these clinical data tables. And remember, these are the ones that contain basically the patient information themselves. So in the person table, we have all the fields. So these are the variables or the columns on the data set, however you're used to referring to those. And then there's some descriptions and the data type, is it a number, a character string, whether it's required as part of the common data model. And then the primary key and foreign key. So in this case, there should only be one primary key typically per table. So for the person table, like I mentioned, person_ID is the primary key. And then nothing else is going to be for this table. And then there's the foreign key flag, and then it also specifies what that foreign key will link you to. So very useful for trying to jump from table to table, say, how do I get to the information that I want, starting from wherever I'm at right now with my data. So for example, the gender concept ID is, it should probably be called sex concept ID. They're working on updating that. But it is not the primary key on the person table, but it does link to a different table, which in this case is the concept table. And it also specifies that when we link to the concept table, we want to specifically look at concepts with the domain gender. We'll talk about that in a little bit. Okay, cool. So can someone else list off one of the other foreign keys on the person table? Hopefully you pulled up the documentation.
Feel free to jump in and talk, guys. We really want this to be very interactive. It's not.
Yeah, you can do the chat, or you can just unmute yourself.
Race concept ID.
Race concept ID down here. Yeah, awesome. So this one also links to the concept table. And here we would look at, in the concept table, at concepts with the domain race. And that'll make more sense when we talk about concepts in a little bit and look at the concept table. But yeah, so a lot of these link to concept table. Here's one that actually links to the location table. So location ID is a foreign key here. And then if we actually go to the location table, I don't know if this link will work or not. Where is our location? Here we go. So this is under health system. Then we see location ID is the primary key on the location table. And so that would allow us to get from the person table to the location table if we wanted to know where a certain patient was located. Cool. Okay, questions on primary keys, foreign keys, anything we've covered so far?
Could you please again go to the location ID table? I'm trying to see the location ID table, but
Yeah, are you able to find it here? It's under the health system data tables.
Okay, thank you.
Yeah, so all of these tables are like in STARR-OMOP, they're all just tables, but in the documentation, they're sorted basically conceptually into these different categories. So you might have to look through different ones. We can go through and check. So clinical data tables, person, observation period, visit occurrence is a super helpful. You're going to probably use that one a lot. Condition occurrence, and so on. Health system is location, care site, and provider. Location is contains information for both the patients and the care sites all in one table, and then you use like the links using the location ID from other tables to associate an address with a given patient or provider or care site. The health economics data tables contain this payer plan period and cost tables. I haven't worked with these very much, but similarly, they have a primary key and a foreign key, so you can link using those variables to the person table if you have a certain person you're interested in looking at, or a list of people in your cohort.
So just quickly, we have not populated and will not be populating the cost table, because we're just not allowed as part of research to get access to financial data. So, but the payer plan period has been populated.
Cool. Great, thanks for the context. The standardized derived elements are basically different ways of looking at the information that is contained in the clinical data tables. So there's like some aggregation here over a certain time period to say, okay, like we saw this patient fill this prescription this month, and this month, and those would all show up as different rows in the drug exposure table. But then we might say, okay, well, how long was that person on treatment with that drug? And we could go look at one of these ERA tables to see more information at that level. The metadata tables, I am not very familiar with. I don't know, Priya, if you want to mention anything.
Yeah, no, they
here.
actually just like, you know, if you want to know which version of OMOP we were using, so Stanford right now, we have our data in 5.3. Our goal is to move to 5.4 at some point, but if you were to get to a place where we're actually maintaining different versions and you want to know which version you are in, that's the kind of information that's in this metadata table. You know, which version of
makes sense.
Vocabulary, yeah, which version of the vocabulary is it? Which version of which version of OMOP is it, and so on.
Cool. Yeah, so maybe useful for reference for your own context, but not containing any clinical information here. Then we have the vocabulary tables, which are actually super important to being able to use OMOP effectively. So the concept table is like we were seeing it being linked in all those foreign keys on the person table, right? So the concept table really does contain like concepts, and that's kind of a weird word to use in the sense like it's not automatically clear what it means. But basically, any kind of thing that is going to show up in the data is represented in the concept table. And so there can be things like, well, we saw gender concept IDs. So like male and female are concepts in the concept table. They have domain gender, and they have an ID associated with them. A condition like like gestational diabetes is a concept, and it could be represented in different coding systems. And each of those would be their own concept, but then they would be linked together into a standard concept. So this is kind of the language that OMOP uses to talk about different events. And it might seem like it's like an unnecessary level of annoyance rather than just like using whatever was originally in the healthcare system for representing that information. But the reason that this is necessary is because OMOP functions across so many different sites, and that source information might be represented in so many different ways. And you don't want to have a situation where just because a given condition is represented with a different code at one site and a different, like another site uses a different coding system, that those things can't be like linked together and say, oh, okay, these are the same condition, even though they show up differently in the source data. So that's why there's been a lot of work that's gone into this infrastructure to be able to connect different ideas across different vocabularies and things like that, different coding systems into concepts.
So I just want to jump in here and say that it's really important to realize that OMOP is not a US-based common data model. It's an international common data model. So for example, the country Korea has completely converted their entire health system EHR data into OMOP. Europe is going the same way. So there are a couple of huge, I think they're putting in a bunch of money in the last 3-4 years. So like Germany, France, Sweden, like all the Scandinavian countries have completely converted their data into OMOP, and all the European countries are sort of heading that way. So because this is an international common data model, it's really important to be able to adopt all different vocabularies, because not everybody uses ICD-9 and 10, for example, and so on. Keep going, Natasha.
Great, thank you. Cool, yeah, so we're already talking about concepts a little bit, but that is the next topic here as well. So I have an example of a particular ICD code that is represented with a concept here. So the ICD-10 code for type 2 diabetes with diabetic chronic kidney disease is E11.22, and that is assigned a concept ID in OMOP. This is the concept ID here, and that's specifically the ICD-10 code E11.22. So that concept is representing type 2 diabetes with diabetic chronic kidney disease in ICD-10. So that alone doesn't help us abstract away from the particular coding system, right? So then what we have is what's called a standard concept. And in that case, for all the conditions, the standard concept has been selected to be a SNOMED code, which is a different coding system than ICD-10, but it also represents conditions. And so the standard concept ID, which this ICD-10 code maps to in the relationship table, which we'll show in a second, is actually a different ID. It's this 4353158. And that technically corresponds to a SNOMED code for chronic kidney disease due to type 2 diabetes mellitus. So you can see these codes are like not quite the same. Like if you just matched on the descriptions, they wouldn't be the same, right? But they're representing the same general concept from a clinical perspective. And so the way this works in OMOP is that any codes that have been defined as having a relationship to this SNOMED code where it maps to this code, they all show up as this code in the data. So it all gets standardized to one system, and that way it's represented, uniformly across all the different source coding systems. The choice of what the standard is, somewhat arbitrary, but it's been made already. You don't have to make that decision. You just have to look up what the standard concept is and what the standard system is for what you're working with. The reason I'm talking about this a lot is because if you don't realize this and you try to just directly look for example, this concept ID in the data, you're not going to find it because this is not the standard concept ID. So this is not how it is represented in the final version of OMOP. This is used internally when we're trying to go from our source data, which does have an ICD code, to the final standard code, but that's not what you would use as an end user to look through our database. You might have that as your starting point and you have to go through it and figure out what the standard code is and then go from there. So related to that, if you do say, you're like, well, I know what the ICD codes are, so how do I figure out what to actually look for in the data if that's not the standard? Athena is a super helpful tool that is maintained by Odyssey. It is just this site here. Priya, did you link Athena already?
Yeah, just give me 1 second, let me drop it.
Okay. You can also just Google Athena Odyssey, and this has all of this information. I already had something up here, but if we search for that particular code, I don't even have to put any more information on it. It will eventually find it. So let me make sure. Okay, I wanted the ICD-10 version. Is this KCD? Is this a different language? Anyways, this is the one that I was thinking of that I was starting from in the source data. And so I can click on that and then it's going to show me all this different information about the relationships. So it tells me that it's a valid code, but that it's non-standard. And then it has these different relationships. So it is it's under the category of type 2 diabetes mellitus and kidney complications. And then the non-standard to standard map is here. So both of these would map. I'm going to select this one because I think it's a better fit for what my original intent was. And then this is the concept ID that I would look for in the data rather than the ICD one. Questions on concepts?
Yeah, so Sarah has a question saying, what does it mean if it says that the concept is invalid in the validity section?
Yeah, so sometimes that I think the typical case I've seen is that means that there is an end date on that concept that was, in the past. So maybe it was a valid code for a while, but it has been retired and is no longer in use. Maybe it has been replaced. So that's a situation of like in the medical system, they changed what they were doing, but there's also situations where this used to be the code that was used in OMOP as the standard, and then it's now been replaced by a different code because they like reconfigured some of their system. So if it's a standard code, it's not going to be invalid. So you can pretty much just check that. If you're finding it in the data and it says invalid, that's an interesting case. I don't think I've come across it yet. So yeah, I wouldn't worry about it too much. But it's helpful if you're trying to collect a code list about a particular topic using Athena. You wouldn't necessarily need or want to include any invalid codes that show up.
Yeah, but like you said, for the most part, a lot of the time, codes that have been deprecated, show up as invalid. So the goal is that they never throw away anything. It's only additive, this vocabulary, right? So they'll never throw away anything. So if you actually have data from a time when it was perhaps valid, you can still link it.
Cool. Okay. So for our first example, we're just going to do it via the documentation, and then we're going to code it later in BigQuery. So if our goal was to determine how old a particular patient was at the time of their most recent visit, what OMOP tables do we need to use to do that? So hopefully you still have the documentation up. If not, I can pull it up, but you won't be able to scroll through it. So from here, what tables would we need to use if we want to determine how old a patient was at their most recent visit? I see person table in the chat. Yes, that seems reasonable. What information would we need from the person table? I'll click on it. So what specifically do we need from this table in order to be able to calculate someone's age at time of visit? Birth_date time, I see in the chat. Yeah, exactly. So I guess what's the other table here that we're going to need if we want to know what their age was at their most recent encounter with the medical system? Visit occurrence, great. So in the visit occurrence table, we only have information about visits really, and then we have the person ID so that we can link it. But you'll notice we don't have like a age variable here, like an age at visit. And this is a pretty common thing in the table. So we don't really want to represent the same information a bunch of different times in a bunch of different tables, right? Like it's not an efficient way to represent it. And so the patient's birth date is only on the person table. So if there's any other clinical tables, they're really going to constrain themselves to just that particular topic, in this case, visits. So it's going to have the start and the end and what kind of visit and who was the provider for the visit, where the visit occurred, and so on, but nothing about, for example, like what conditions they were diagnosed with in that visit, or how old they were, or what their race or ethnicity was. So cool. So we have the visit occurrence table. What a variable do we need from this table if we're going to calculate age at most recent visit? Visit start date, yes. I mean, I guess there's sort of a question of which of all these date variables you should use, and it depends a little bit on your use case, but I think visit start date is a good default assumption, or whatever the condition underscore start date, visit underscore start date is a good default one to choose. So if we have our visit start date, we have our person or a birth date from the person table. What do we need to do in order to be able to calculate the difference between the visit and the birth date?
So remember, the visit occurrence table has all the visits.
It's kind of an open-ended question. There's different ways to approach it, but what would we need to do if we wanted to make this into a single table so we could do just one calculation rather than having to look it up in two different places?
Guess you're gonna inner join them probably, and then calculate it within the joined table.
Yeah, for sure. I guess we could do an inner join. We could do a bunch of different kinds of joins, but the main concept here is that, now the word concept is like overloaded, but the main idea here is that we do need to join the two tables. And what variable would we use to join the two tables in this case?
Person ID.
Yeah, exactly. So that's actually, I think the only variable that is on both of these tables, right? So if we want to link between the two, we're going to need to join on person ID. So associate rows with a given person ID in one table with rows with that same person ID in the other table to be able to calculate age at visit. Cool. Okay, so we're going to come back to that later. Like I mentioned, there's a lot of resources for STARR-OMOP. I'm not going to go through all these now. Actually, maybe I should show a few of these. We have a lot of resources that we don't think people are that aware of. So just as a heads up, there is this like technical specifications documentation that talks a lot about like sort of the schema and mapping and the different tables, like a lot more detailed information than what I went over today. There's also past user questions that we've answered. This is mostly Priya maintaining this or answering these questions, but so there's like access questions, Atlas questions, and so on. So lots of other resources here. We'll come back to that at the end as well, but just a shout out to all of the things that we have available. Okay, next section.
Could I ask?
Oh yeah, go ahead.
For the Stanford specific data tables, like you mentioned, like flow sheets as an example, would the best place, the technical specs document, is that the best place to kind of learn, since that wouldn't be on Odyssey?
Right.
I'd have to look at the technical specs document to learn more about that.
So the technical specs doc, and then there was, I also dropped it a little while ago in the chat. There's a STARR-OMOP users doc. And usually when you get access to STARR-OMOP, you know, I think usually you get this sort of welcome email with all these links. So those are the two places to go look. And then if you have questions, like feel free to, you know, ask us questions on the Slack or come for office hours. You know, one of us will try to get back to you if you ask on Slack.
Thanks.
Yeah, you're right that none of that stuff will be in the CDM documentation. So you do have to look elsewhere. Great. So that's STARR-OMOP and a little bit how we might navigate between the different tables. Now, the tool that we're going to be focusing on to actually do that effectively is Google BigQuery. And so I don't know how familiar folks are with Google BigQuery, so I'm going to try to do a high-level intro and then just show a whole bunch of examples of what you can do. Google BigQuery, I was even struggling to figure out how to define it in like a pithy way when I was writing the slides. So I just quoted from their own site as a cloud-based data warehouse and powerful analytic tools, like set of powerful analytic tools that come along with the data warehouse. So it's kind of hard to conceptualize, it's like, you know, floating around somewhere. I think there's a question, Priya, about accessing one of the docs. So BigQuery is an awesome tool because it handles a lot of the behind the scenes like storage and optimization problems itself, like in the BigQuery infrastructure, regardless of the specific users. And so it's super fast, like it's really nice. You can work with really large data sets really easily. And there's different ways to access it. You can either use command line, like a terminal window, if that's what you're comfortable with, or if that's helpful for your context, or you can use the BigQuery console. You can also access it through Python and R, like you can connect to BigQuery and then pull in data there. But today we're focusing on the Google BigQuery built-in console. And it has a lot of awesome features for being able to work with data. And one thing to keep in mind is that both storing and querying data do cost money, but not actually very much. So we'll do some examples for that and talk about ways to minimize costs, but it really isn't a prohibitive thing for most researchers. You need to be mindful of it, but you can still do most of the exploration and stuff like that that you want, and the costs will not be crazy. So there are many features in the BigQuery console, and I'm going to show instead of just telling everyone what those are. So you should all have access to the training project, this RIT STAR training in Google BigQuery. Priya and I have been adding everyone over the last few days. So Priya just dropped the link in the chat. So if everyone can please go to BigQuery and pull it up, at least try to.
Yeah,
If you
hang on
can't,
one
it's okay. You
second. I
can
was
follow along.
answering. Yeah, I didn't drop it. Give me a second because I was answering that question, but why did I lose this? It's bizarre. I'm sorry.
I see I guess you linked this like about BigQuery instead of the project. Okay.
Yeah, no. So they want the project, right? The training project.
Yeah.
So,
here, I think I have it. So I sent a link to everyone, so you should be able to grab that if you want to follow along. So it should look something like this. So if you just go to Google Cloud is like a much bigger entity than just Google BigQuery. Google BigQuery is like one feature of that. So if you end up on Google Cloud, you'll see all these different options. You want to find the BigQuery option and then go to the SQL workspace. And that's pretty much where we're going to live for today. It should look something like this. You need to make sure to select the appropriate project. So I don't know how many projects most of you all have access to. It might only be the STAR training one. I have access to other ones, but we want to all be in this School of Medicine, Research Information Technology, STAR training project for right now. Make sure that you are logged in with your stanford.edu account if you're having trouble accessing.
yeah.
Cool. Okay, so the first awesome thing about Google BigQuery is the Explorer. I love the Explorer. You just get to like see what is there and what you have access to. So this is inside the training project, and you can see that here. It's like I'm inside this dropdown, and different people have created data sets in here as part of the training. And then we also have dropped this, a recent cut of the STARR-OMOP CDM5 DID 1% light, so like the minimum data set that we talked about before, with a date of October 30th. So this is the data set we're going to be working with today. You'll notice that if you click on the data set, and that is the appropriate term for this level. So real quick, we have a project is sort of the highest level. What project are you in? Then we have the data set, which is like an aggregation of tables. And then under the data set, we have individual tables. So those are the three levels that you would need to specify if you're going to be exact about what table you're looking at in BigQuery. You say project, data set, table. So we're in the training project, we're in the data set, STARR-OMOP CDM5, DID 1% light 2022 1030. And it gives us, typically, if someone has filled out the descriptive info about the data set, we can get a lot of useful information just by clicking on the data set and reading this information that is provided. So we can see the date that it was created and modified, where the data is located, which is kind of a loose thing since it's in the cloud, but it's more important if you're trying to transfer data and things like that. And then some basic metadata about the data set as well. So this is a good place to start if you're just trying to figure out like what data set you should be using and you have multiple options. You want to check this, check the dates, make sure it's what you're expecting or the most recent one you have available to you. Then from there, we can go look at specific tables that are inside this data set. So I can use this dropdown, and let's actually look at the concept table and see some examples of the wide-ranging kinds of things that are in here. So when I first click on a table, and this little, like, it looks like a calculator to me. I assume it's supposed to represent a table, but I think it looks like a calculator. This symbol means that it's a table. When I click on it, I get a lot more options for things to look at and a lot more information. So I have the schema, details, and preview are the three tabs that I'm provided for a table. The schema is literally the schema of the tables. That might mean something to some folks and not to others. So it's like the list of variables or columns or fields that are in that table, what data type they are, integer, string, date, and then the mode, which is something that we've set to align with the common data model. So this doesn't mean there's going to be useful information here. It just means it's not going to be empty. So it might say something like unknown. That's different than a null value, which is just empty from BigQuery's perspective. So this is a great place to start if you're going to work with a table, because you can see exactly what variables are in it. It complements the documentation from the CDM about what variables you can find in what table and what each of them mean. But you can find like exactly the names and stuff here. Then we can look at details for the data set and see, again, when it was created. You can see how many rows it is, which I think is super helpful. Sometimes it'll be 0, and then you're like, oh, okay, well, that's not useful. And sometimes it'll be very few, and sometimes it'll be a lot. So it's good to have a sense of how big your table is before you start working with it. Next, we have the preview function, which is probably my favorite of all of these things. So this allows you to just get your eyes on the actual data really quickly and with no cost associated. So this is something that Google BigQuery provides free as just sort of a nice way to work with the data sets. And so this is literally the first like 50 rows of this table with all of the variables. And so I think it is really useful to actually be able to see what's in these. Like, this is so much more informative for me than seeing, oh, concept name is a string. It's like, oh, okay, great. Like, is that what I want? Is that not what I want? The preview is super helpful. So I can see, oh, okay, here's my ID. This is actually like a human readable, useful name for what's the concept. Okay, I can see some different, like, I get a sense of what a domain is in this case. It's a procedure or drug or observation. Makes sense, what vocabulary it's coming from, and so on. So I recommend looking at the preview for your data sets anytime you're about to start using them, even if you've worked with them before, just to remind yourself of what's there and what format it's in and what kinds of things you might want to be looking at. Questions on basic functionality and features of BigQuery so far?
So I think there was one person who had issues and could not access the training project, or rather they could see the training project, but could not see any tables in them. So I was wondering if we should just take a few minutes and just make sure that everybody can actually access the training project.
Sure. Yeah, are some folks able to access it okay, at least? I see. Okay, I can see Ayers nodding.
Yeah.
Yes,
Yeah,
yes. Okay, awesome.
Yeah, the same thing's happening to me, and I just checked some other projects that I've been able to look at before are now doing the same thing, where I can open the project, but there's no Explorer tab and there's no tables.
No Explorer tab. Interesting.
Interesting.
Can try refreshing.
Yeah, I've tried opening a different browser.
So one thing is that you actually, just for this training project, you do not need to be on VPN. Not that it'll make a difference, but sometimes VPN says, oh, I can't do video because I'm on VPN, and just takes up a lot of bandwidth. So
Yeah, I don't know if I have anything. I'm not sure how much troubleshooting we can do on an individual basis. We'll make sure to get you set up like shortly so that you can go through this, but for now you might have to just
I'm making
follow
sure that
along with
everybody
the
has access
video.
to both, but yeah, I can. So as far as I know, it's Alyssa and Meredith, right? I'll remove you and re-add you. Oh, there's one more thing that actually I found that some people works for some people. Try clicking, you know, where you up there you see add data. And yeah, just click add data and then say star a project by name. Yeah, and then here type in the name of that. So it's som-rit-star-training.
Yeah, I don't even have that search bar.
Okay, then there's something else going
Intriguing.
on.
Yeah.
Okay. I think I'm going to continue with the content, and yeah, Priya will try to get things sorted out, but if not, you might have to come back and follow along later with the recording. Okay, so this is a great way to just get familiar with your data set, your tables that you have available to work with, and even just being able to see the list of all the tables here, I find super helpful as a reminder of what I'm working with. We haven't actually done anything yet, we've just looked at stuff, which is great. But if we want to query the tables, this also is a really nice shortcut. So if I've clicked on a table, I can go up to query, and then it'll let me choose, do I want a new tab or a split tab? I have a giant screen, so I like to split tab, but if your screen is smaller, you might do just a new tab and it'll just show up here. And then this, and so you can see that it basically set up almost a full query for me already. And the part that's nice is it'll like auto fill in the full name of the table with the weird backticks that are not quotes. If anyone's been struggling with that, it's the backtick is like in the upper left corner of your keyboard, and it is not the same as a single quote. That won't work. So just a heads up, annoying things. But yeah, it'll auto fill out the full name of the data set. And you'll see that this has the same structure I was mentioning before, where we have the project, then the data set, and then the table listed. And that's like the full specification for this particular table. So it's complaining, which is also nice that it's complaining because this is not actually a full query yet. So I haven't told it what to select from the data set. The most basic thing, which I don't recommend, but just to show that it'll now say that it's a real query, is I can do select star, which just means select everything from this data set. And so now I have a query set up, like ready to go. And also we have this other super cool feature of Google BigQuery, which is that it like auto validates your query as you're writing it and tells you if it's like a legitimate query or not, or if you mess something up. So if it is a valid query that Google knows how to execute, then it will have this check mark and it'll tell you how much data will be processed when you run the query. If it is not a valid query, so if I don't have anything here, or if I say like concept, maybe I mistype ID as JD or something like that. So this isn't a variable that's on there, right? Because I misspelled it. So now like it tells me that's not a real thing. Did you mean this other thing? Like, oh yeah, okay, great. And it's not telling me how much data this query is going to process because it's not a valid query. If I run this, nothing will happen. You won't get charged because it's not going to actually touch any data. So if I fix this and say, oh yeah, you're right, I actually just want concept ID, then it'll fix it and tell me how many megabytes this will take to run. You'll notice that if I just say concept ID, that ends up being quite a bit smaller. So that's only 61 megabytes if I select concept ID, versus if I just did select star and I'm selecting all columns, that's quite a bit bigger. So this is the most useful way to try to keep your query costs down, is to be mindful of how much data you're touching and try to minimize that for each query. We'll talk a little bit more about pricing, but for now, I just want to run a basic query. So the goal there was you can set up a query really easily by going to the table you're interested in and then using the query tab here. You can also click on a variable in the schema if you're like, oh, I want to query the domain ID variable, and it'll copy it over. I think this is less useful. I can copy it myself. I prefer to get the full table name, but it will do that for you as well. Okay, so we have a super basic query here. We can also do some nice things to save this query. So we have some different options. We can save just the query itself. So that's literally just the text. It's not like the results of the query. I haven't even run this query yet. Let me do this. And we're just going to run this as an example since I haven't run a query yet. Okay, so when I hit run, this is the output that I get, which is the query results. And I usually stay mostly in this results tab, and it's just literally showing me the results of what I asked for above. So in this case, I just asked for it to give me this particular column from the table. And so that's what it gave me. And you'll notice that it has this limit 1000 on here by default, which just kind of helps minimize the amount of info that it's dumping into your browser. It doesn't actually reduce the costs, but if you want, you can change this to be something smaller. It'll kind of give you the output a little bit faster there. and you'll still have something to look at here. There's also some different formats of the results here and some execution details. I typically just stick in the results tab, but depending on what you're doing, you might want to explore some of these other options as well. Okay, so I have some results. Say I need to go work on something else and come back to this later. I can save the query so that I don't have to worry about keeping this tab open forever. And if I do that, it's going to ask me to give it a name. So I'm going to do test query workshop. And the default here is to save it as personal, which I think is usually the right choice. So clicked out and it went away. And so I can hit save here, and you'll notice it will name this tab, which is honestly very helpful just for keeping track of what's going on. And then when I come back to this project anytime, like I can log out of everything and open a new window and come back and look at under my saved queries, I will see this query show up. And if I close out of it and then open it again here, it will give me the same query that I had before. If I want to save the output of a query, I can do that as well. I can save a view. And what that does is it looks like it creates a table. It's kind of a table, but what it actually is like saving the instructions to create the table. So save this, and I saved it under my data set here. And so I've created a view now, which you'll notice that it has this different symbol here. I have no idea what this looks like. It's like the US, but in dots. I don't know what shape this is supposed to be. If anyone knows, then I'm interested to hear. But you'll notice that it's different from an actual table, which has this, again, calculator looking thing. When you create a view, you will get some of the same stuff as if you had a table. So you'll see the schema. I only have one variable. It's not very exciting in the details, but I will not have the preview tab. And that's because the table doesn't actually exist yet. It's just the instructions for creating it. And you can see down here, I actually have the query that I used to create this view. So this functions like a table. Like I can write a query of this. Let's do that actually. Query in split tab. Let's select, I don't know, the highest concept ID from what I just created. And it'll function like a table in terms of querying, but it doesn't actually exist until I run the query and prompt it to execute the code that constructs the view. Okay, we have someone saying, it says no data to display when you try the query. So it might mean you're querying an empty table. I would check that. It might mean that your query just doesn't return any results. So like if I said select concept ID where is greater than this one, which I know is the max already. So then I get this message.
So I think it's Natasha Flowers. You're trying select star from the concept table, and you're getting.
Yeah, it just says request contains invalid argument whenever I do select star from that concept table.
Oh, interesting. And you're under the more recent, so you see there's two DID 1% light cuts. Are you under the 2022 1030 cut?
Yeah, I am.
Okay, let's do something. I mean, it's almost time for that break we're going to take, right, Natasha? So I was this is just a suggestion. I could, I was going to say, can I do a breakout room? But no, this is a webinar. I can't do a breakout room. But if you do want to take a break, and the couple of people who were having issues, if you don't mind staying back and you could share your screen, we can just try to troubleshoot, because it looks like it just must be a typo or something.
Yeah, that's fine.
I've never seen any of these, some of these errors. So
always exciting. Yeah, I want to go through, talk about pricing briefly for BigQuery, and then we're going to wrap up that section. We can do a brief break for troubleshooting or coffee or whatever everyone needs, and then we'll move on to the second portion. So let me go back to my slides real quick. So minimizing BigQuery costs. To be clear, I'm not going to go too much into the SQL syntax. I'll do it a little bit later in the examples, but there are tons of resources online about how to use SQL and construct a SQL query. So we're not going to talk about that too much today. There's also resources for STAR specifically that I'll link to. But some ways to make sure that you are minimizing your costs when you're working with BigQuery is using the preview functionality that I showed. That's free. One note is that it's not like a random sample of your data. It's just whatever BigQuery has on hand. So it's like whatever is cached already. So it can change from run to run, and it's not consistently like a random sample. So just be warned that that might not be representative of the rest of your data, but it's still useful to get a sense of, you know, what variables are there and how they're filled out. Definitely take advantage of that since it's free. When you're setting up a query, you should select only the columns you need. So like select star is, I mean, occasionally you need to look at everything, but not very common. So typically you should look at the schema, you should look at the documentation, say these are the variables that I need, and only select those variables from the table. You can also exclude variables, like if you need almost all of them, you can still like exclude the ones you list instead of selecting those.
a lot of people often say, hey, if I just put a limit 10, then am I not just going to look at 10? So no, the limit function actually happens after it's touched all the data. So just FYI, that's only for display purposes. It is actually query.
Yeah, exactly. Yeah, so the limit isn't going to help, but selecting only the columns that you need is going to actually reduce the amount of data that BigQuery has to handle. And so that's going to reduce your costs. You can create a temporary table if you're querying like the same like subset of people over and over. So rather than taking the whole person table and then subsetting to just what you want and then joining on something else, you can create a subset that's just what you need and work from there so that you don't have to re-query the full table. You do that similarly to how we created a view, or you can do it in the SQL itself. I also recommend checking the query validator, which is that little, you know, the text that I showed you about whether your query is valid or not, and seeing how much data it says it's going to process. And that's actually another good thing. Like if you're not sure if something is going to reduce your costs, you can change it and then see what the query validator estimate is for the amount of data that it's going to touch. So you'll notice that if you add a limit statement onto the end of your query, even if you limit it to one output, it's not going to change the total amount of data that that query is going to process in the validator, because it's going to do all the processing first and then just output however many rows you specified at the end. The cost for Google BigQuery is $5 per 1 terabyte per project, and the first terabyte per month per project is free. So this is, I don't even know how to say this, a very, very small number of like fractions of cents per megabyte. And so it's really not too bad, especially if you're working with this 1% cut of OMOP. And you can use that to develop all your queries, test them while you're like running a lot of queries and maybe messing them up and not doing what you want and then having to rerun them. And then you can run on the full OMOP once you have your queries set up properly. So as a test, I just queried the entire condition occurrence table, like literally did select star on the condition occurrence table in the 1% cut. And that is 7/100 of a cent. I don't even know. It's a really tiny amount. So basically you don't have to be too paranoid about querying if you're working in the 1%. And as long as you're careful about subsetting to just the variables you need, you should be pretty much good to go. There is a reference from BigQuery on costs as well that is linked here that pretty much has these tips plus some additional explanation. So I would keep those things in mind. Any questions on pricing before we break? No? Okay, awesome. Then we're gonna pause here. And yeah, if anyone wants to stick around for troubleshooting, feel free. Otherwise, we will come back at 2:15, so in 5 minutes. and resume the rest of the presentation, which is mostly just going to be examples of all the stuff we've talked about already. So we'll see you back here in 5 minutes.
All right, so really quickly.
Should we stop recording, Priya, or do you want to keep it on?
Oh, yeah, let me stop recording. That's a good idea.
Awesome. Okay, so to start with, let's go ahead and actually do the example that we talked about before with age at time of visit. So we've already figured out like what tables and what variables we need. We just need to write the actual SQL to do this. So as a reminder, we're trying to figure out age at most recent visit. I picked a random person ID just so that we aren't doing this for everyone to start with, but we're saying, okay, we know we're interested in person ID this for some reason, and now we're going to try to find how old they were at their most recent visit using Google BigQuery. So when I get started writing a query, I like to make sure that I write some notes for myself about what my goal is, because it's really hard to go back and scan through all of your queries and know what's going on. So you can do a comment with just 2 dashes, and then I'll do something like check age at most recent visit for person, and then I'm going to copy over the ID so I don't mess it up, something like this. Cool. So, okay, it's complaining because I don't actually have a query in here, but that's fine. So if I want to query the person table, so we said we needed person and visit occurrence, right? So it doesn't really matter in this case which one I start with. I'm going to need to join both of them. And so I'm just going to go ahead and start with the person table, and I'm going to use this functionality. Let me do this and copy that over here. So I want to select, I need person ID because we said that's what we're going to join on. And then I need birth underscore date time. And you see how it's autofilling here? This is another amazing feature of BigQuery is it's autofilling the variable names. It'll suggest multiple ones if there's different options for the autofill. So I can just select that. I also have the schema open here. So I'm like looking at it while I'm typing it. So the odds of me screwing up the name are lower. So I want person ID and I want birth date time from the person table. And when we're building queries, I like to run them a lot and just like check that things are working as I wanted. So I'll go ahead and add the restriction to the person ID. I'm going to take the limit off because I don't need it. I'm restricted to this person, and let's check. Okay, it's pretty small and it's a valid query. So I'll go ahead and hit run. Ta-da, we have our person ID and their birth date. I do, like I said, recommend running your query regularly while you're building it, because it's just much easier to keep track of where you're at and what data you're working with as you're sort of building up your query. Okay, so we have this. Another cool feature that actually Priya just told me about the other day is under more, you can hit format query and it'll like make it nice and pretty for you and split it up into all the different sections. I think that's cool. Sometimes it's overkill for a really short query, but if you have anything with like multiple clauses, it's really helpful to have it split up just for readability. So, okay, we have most of our query, and now I need to join on the visit occurrence table. So we can go ahead and just specify, my default is a left join. Like I said, in this case, it doesn't matter because we're restricting to just this person ID and I already know it's in both tables. So I'll do a left join, and then you can also grab the table name. You can just copy it from the table info tab if you want and add the backticks. Oh, that's not where it should go. It should go here. Left join this table. And then you can see it's telling me as I go, okay, you have to have an on or a using clause. So it needs to know how to join these tables. I'm going to use on, my default. And then I need to be able to specify which of these tables I'm referring to now that I have 2 different ones in my query. And so I'm going to give them, and I think it's technically called an alias. I'm going to give them a nickname basically. So I'm going to call this one per, like for person, and this one viz for visit. They can be longer than that. I just try to keep them short but readable. So I have my person table and my visit table, and then I'm going to tell it to join them on per.personid equals viz.personid. So this is the variable that's the same across the two tables, and it's hopefully suggesting that. Thank you. So this is my join, and now it's telling me that the column name person ID is ambiguous. And so this is because and it's actually telling me the row and the position also where it's ambiguous. So nice. So what it's saying here is it doesn't know whether this person ID should be coming from the person table or from the visit table. In this case, it doesn't matter because I'm joining on that, so they have to be the same, but it still wants me to specify which table it should be. So I'm just going to pick the person table for now and put this here, and then I need to do the same thing up here. So anytime a variable appears on multiple tables, you're going to need to specify which table you want it to pull from. And sometimes that's overkill, but often it's necessary. So it's a reasonable request. Okay, so I have joined this table. I'm actually going to test run this so you guys can see the process a little bit. I joined my table, but I don't actually see anything because I didn't select any rows from that table. So it's not enough to just do this join. In fact, it's pretty silly to do it like this because I'm asking Google BigQuery to do the join, but I haven't used it for anything. So I'm going to pull my other variables down. So I want from the visit table, let's see what we have. Visit start date, we said was what we were going to use. So I would like to add visit start date to my table. Okay, great. Now if I test it. Okay, awesome. So now we can actually see when these visits occurred. It looks like there's a little cluster. Well, there's two of them that are on the same day, and that's probably just an artifact of how we record the visits. It's probably not like two separate things happening. And then another one later. So this is our most recent visit. From here, we could do a few different things if we really wanted to calculate the exact difference. So we could find the max of visit start date and then subtract that, or we could just subtract for all of these and sort to find the one that was like the most recent. So there's a few different approaches from here. I'm going to leave it at this for now because we're going to do some more complicated examples later, but I just wanted to show sort of a basic query setup and all the different features that it has to help you through that process. So there's all the auto checking, autofill variables, the query validator, super useful for making sure that your query is set up properly. Questions on this? That's in the chat. Cool. Awesome. Okay. For those of you who are following along, were you able to construct a similar query at least? Yeah, and it runs. Yay. Okay. Awesome. So that's just basic querying using all of the different nice features of Google BigQuery. But I also want to talk a little bit about like a higher level perspective on querying. So what I'm calling strategy for using BigQuery to explore your questions. Sorry, no, for what? I don't know what that's referring to, Natasha. Oh, okay. So the strategy to construct queries, and it's more important as you build up more complicated queries, is like these different stages to try to make sure that you're staying on track, that you know what is going into your query, and that you can catch and troubleshoot problems as they come up. So this is my advice. I'm a data scientist, and like that's what my background is, like my prior work, and I have a master's degree in data science. So that's kind of what I think is interesting about approaching this. And that's where this sort of strategy is coming from. And so the first thing is, before you do anything with the data, definitely get yourself familiar with it first. So that's why we spent all this time at the beginning of this workshop talking about STARR-OMOP, talking about the documentation, talking about how to look at the data set in BigQuery and look at the tables in BigQuery. So yeah, using preview, you can do like a very basic query. If preview isn't giving you enough information, you can look at the schema, you can check the table size, all of this stuff to get yourself set up properly to do your queries. If you don't do this, what you'll often end up doing is like starting with the wrong tables or the wrong variables and just getting very sidetracked, and it'll take longer to get to the information that you want than if you spend a little bit of time up front to make sure that you're in the right place for what you're trying to do. Next is, like I mentioned before, to build up your query one layer at a time. So I always try to start with like the simplest query I can think of related to what I'm trying to do. And then I add on complexity sort of one piece at a time. And I look at the results after each piece that I add. Otherwise, you'll end up with this huge query and it either won't run and you won't know how to fix it, or it will run and it'll give you results that look weird and you don't know why. And it can be really frustrating when you're at that stage to try to figure out what happened. And so I think it is much more manageable to work up a little bit more slowly as you go, and to keep checking each stage so that you know your understanding is correct and is matching with what you're doing in the query. The final thing, which is always true in data science, is to be skeptical about your results. So a good practice is to state sort of your expectations around what the results are going to look like beforehand and make sure the results match. So for example, if you are studying a rare disease, you could say something like, I expect that there will be like a few, but not a lot of people in the database that have this disease, right? It doesn't have to be super specific. But for example, if you suddenly did a query and found that 99% of patients had that, like that would be a clear red flag that you did not set up your query properly. Similarly, if it's something that you know is in the data and you're getting no results, that's a red flag. Or if you know it has to be less prevalent than this other thing. So it's if you do have some context going in about what you're expecting, that can really be helpful at catching problems early on. You also want to sanity check your query at multiple stages. So that goes hand in hand with looking at the results after each step. So again, if you wait till the end, it can be really hard to untangle all of the pieces and figure out what's happening. So I recommend looking at it along the way. And then keep coming back to the documentation. Your understanding of your question might evolve as you're working with the data and as you're querying the data. And so it's useful to go back again to just double check, like, oh, I thought I was going to use this variable. Now I'm doing something slightly different. Maybe there's a different variable I should be using or something along those lines. So just try to keep anchoring yourself in the, all of the information around the data as well to make sure what you're doing is really answering the question you're trying to answer. So to demonstrate that, we're going to do a sort of more complicated or more open-ended example question. And this was an actual user question, which I tweaked a little bit. So someone wanted to get more complete information about the units on a particular kind of measurements that were in the measurement table in STARR-OMOP. And it was for things like this albumin creatinine mass ratio in urine. That's like the lab of interest. And this person had noticed that it looked like about half of the measurements didn't have units associated with it, which makes them not useful, right? If you just have a number and no units, it's like, okay, well, what does that actually mean? So this is something that I sort of dug into to try to figure out what was going on in the data. And so I would like to do that with you all together right now. So the very first thing that I do whenever, let me just save this in case anyone wants to come back to it later. But the very first thing that I do, well, okay, maybe the second thing. The first thing I do is like, what tables am I working with? So I would like this to be more of an interactive example. So I'm going to try to ask questions. If you guys can follow along and make suggestions for what we should do next to investigate this question, that would be great. So yeah, does anyone know already what is the main table that we're going to be interested in for this? I see measurement table in the chat. Yes, I agree. I like to keep my tables in the left pane and my queries in the right pane. I don't know, it makes my brain happier that way. So I always move the tables. You can just shift them between the tabs. So, okay, so we have the measurement table. These are our variables. So, and we're interested in units, right? The person was saying that we didn't have unit information. So what variables or what fields here do we think that they might be interested in or that we should check out? Unit source value. Okay, good. What others? There are others that have the word unit in them. Measurement source value might be interesting. Yeah, so technically all of these variables could be helpful clues, but like if we're just trying to say like replicate the basic issue of this person saying we're missing units. Okay, like what does that mean, right? Like they didn't tell me what the variable was they were looking at. So to start with, I'm just trying to see like, okay, what are they looking at? How can we check if that's actually what's happening? So someone said unit source value. What's the other unit variable on here? Unit concept ID, great. Okay, so that's actually where I'm going to start because the concept ID is sort of the main representation of the clinical information in STARR-OMOP. So my guess is going to be that that's what the person was looking at when they were saying that we were missing units. So I'm going to start there. Let me grab the table name. And so we're going to do select unit concept ID from table. And actually, I didn't do all of the steps that I asked you guys to do. So let's go through a little more detail. So, okay, so we said unit concept ID and unit source value were the two we had identified. So let's actually look at them in the preview. Oh, I'm in visit occurrence. Preview. And just see. Okay, so here's unit concept ID. Good news is it looks like it's filled out for at least some of the data. So that's a good sign that that's a field that we should be interested in. This range low and range high actually looks like it could be, I don't know, relevant also. And then unit source value is also filled out. And this is like human readable also. So that's super helpful, right? Is that we can see what we're actually working with in terms of the units there. So cool. Okay, so both those fields look interesting. You'll notice like some of these look like they're completely null, and so they might not be that useful, but these ones look like they are filled out. So let's check the unit concept IDs. And the first thing I'm actually going to do is see what kinds of unit concept IDs are on here. And I'm going to go ahead and restrict it to just the concept that the person had said they were interested in. So this albumin, creatinine, mass ratio, and urine. So I'm going to go to Athena. Cool. I'm guessing it's this code. Again, I'm going to verify all of this with the person eventually, but I'm just trying to replicate what they were telling me was happening to make sure I understand the problem. So here is the concept ID that I'm going to use for now. And so I'm going to select the unit concept IDs from here where the measurement concept ID is equal to that. And for now, I'll just go ahead and, well, what do you guys think? What should be the next step? What'll be useful for us to look at here? Like, should I just run this query or should I add some more, sort of manipulation of the data to give us something useful to look at? There are many ways to approach this, so there's no one right answer. Distinct units. I like that idea. Yeah, so for folks that are familiar with SQL, if I asked for distinct unit concept IDs, then I get just all of the unique possibilities rather than like a list of literally everything. So let's go ahead and run that. Okay, there's 4. That's a very manageable number of options for us to look at. one thing you'll notice is like these numbers mean very little. So actually, okay, I see null is in here. So I know that means something. 0 looks suspicious. Like it doesn't look like a typical unit concept ID, right? It would be weird for that to just mean a particular set of units. So that might be something suspicious. But in general, because everything is listed in concept IDs, it's hard to know what's going on in your data unless you attach the names to the concept IDs. So that's what I'm going to have my next step be. And this is something I do really early on in most of my investigations, is I'm going to say, what do these concepts actually stand for? And to attach the names, I'm going to use the concept table. So I don't know why it like has everything vanish sometimes. Actually, I think I can just, so you can also search keywords and stuff in the Explorer, and that's very helpful. So I don't want SynPuff. I think this is the old one. Yes. I would like this one, and here's my concept table. Pull that up. Cool. So what I want is, I have the concept IDs. What I want is the concept name. So I'm going to go ahead and join on I'm going to join the concept table. Oh, what happened here? That was not what I wanted to do. Okay. So grab the concept table. Give these names so I can specify which one I'm talking about. And now I need to join on a variable that is on both of these tables. Anyone have any ideas for what variable that should be? Actually, maybe I should. So I'm going to put the concept schema on the right and the measurement schema on the left. So, and I'm interested in the unit concept ID. So what variables should I use to join these two tables to get the names of the unit concept IDs? Okay, Meredith says unit concept ID equals concept ID. Yeah, so this is sometimes a tricky thing to think through. You just want to be careful, because you'll notice on the measurement table, there's a measurement concept ID, there's a measurement type concept ID, there's an operator concept ID, value with concept ID, not that one, measurement source concept ID. There's a lot of concept IDs on this table, right? And they represent different things. And because I'm specifically interested in the unit concept ID, I need to make sure to start from that one. But in the concept table, these are all just called concept ID. So the name is a little bit different. So I'm going to join on mesh.unit concept ID equals con.concept ID. I forgot the on. And then I'm going to actually get that name. So you can see here it's autofilling for me. I want the name of the concept. So let's do this again. Cool. Okay, this is much more informative now, right? So now I know, okay, these two seem very reasonable in terms of units, milligram per gram of creatine. 0 is no matching concept. So, okay. And then null is null. So at this point, I don't really know if the original complaint was about the nulls or about the no matching concepts. I don't know how prevalent these two things are in my data. So the next step for me, and again, this is something I'm going to do super frequently in investigation, is basically get frequency counts for a particular variable. So does anyone know how to get frequency counts for unit concept ID using SQL? Might need to unmute, or you can try to type it out in the chat. That's fine too. I'll give you a hint. What should I, maybe I'll just do the first. Okay, so I've already pulled out the variables that I want, but rather than selecting distinct, I actually want to group on these variables and get a count of how many times each of them appear in the data. So there's a few changes I'm going to make to my query to make that happen. I'm going to keep these variables, but I'm going to group by them. So I'm adding another clause to my query. Okay, so that's fine, but I haven't told it to actually count the number of occurrences yet. So a typical format you'll see for this is just to say count star, and this is just going to be count how many observations, how many rows. I'm not even specifying which variable. I could also do count unit concept ID, and that would give me similar results, but this is sort of my default syntax for here. So let's go ahead and see what this looks like. Okay, so you can see I have a new variable here, which kind of makes sense. Like I told it to do this variable and this variable and this variable. It had to create this. It didn't know what it was already. And so it's given that like a default name here of F0 underscore whatever. That's not a super helpful name. So I'm actually going to name this variable I've created, and I'm going to call it n rows, which is sort of my typical naming convention for number of rows. It almost always applies in this case. And so next time I run this, it'll replace this with that name since I've given it something to call it. But even from here, we can already see what's happening to some extent, right? So, okay, both nulls and zeros do occur in the data. The null is quite a bit more common. So looking at this, what my instinct is well, I guess kind of do math in my head, but also I'm like, I would really like to know what proportion of all of these results are null, because the complaint I got was that about half of them were. And so it looks like that might apply to the nulls. Like this looks like it might be about half of all of them, just based on trying to add numbers in my head. But I would like to attach the proportion just to make sure. So the syntax is a little funky, but I really like this way of doing it because you can just do it really concisely. I'll try to explain why this works to get the proportions next, but for now I'll just write it out. So the tricky thing here is that what I want to do is to get a proportion. So I want to divide the count for each category by the total. But I've grouped by these specific variables already. So I need to like ungroup to get the total and divide by that. I could do that separately, but I'm going to do it in the code using this like shortcut that I found. So let me write this. I know this looks intimidating because there's way too many parentheses in it. Basically what I'm doing is I'm doing count star again. So that's the same as what I have here. And then I'm dividing by, I'm dividing by the sum across all of different groups in here. So this is called a window function. If you're familiar with more BigQuery, you can look them up. They're pretty cool. But I'm basically collapsing back over the different groups that I told it to split into here. And I usually call this percent rows. Maybe it should be called like fraction rows. But when we do this, we can see, okay, it's you notice that it's like reordering it each time, but we can see that our null values are actually almost exactly 50%, 0.5 of all of the rows that we have in our data. So personally, I always do both counts and proportions when I'm doing these kinds of summaries, because I think both of them give you different insights into what's happening in the data. It's good to know if you're dealing with tiny counts or huge counts. It's also good to know what proportion of the data that represents, because that's typically the thing that you have more expectations around, or that is more telling to us as people, is what the proportion is. I will put this syntax in the chat because I realize that it's too many parentheses. Yeah, Meredith, that's correct. So if you use over and you don't specify a variable to partition over, then it just does it over the whole group. That's why we get the total back from this. I know. I spent like an hour one day Googling to try to figure out a way to do this like in a concise way that I didn't have to like do a subquery, and I was very pleased when I got to this. and now I just have to remember how many parentheses to type. So hopefully it benefits someone else as well. The other nice thing is then like, so if I wanted to change these variables, like say I want to do something different here, like measurement type concept ID, like all of this other infrastructure stays the same, right? So like this is all, the count star and the percent can all stay the same. One other shortcut, this isn't really the main focus, but I think it's fun. So you don't have to write out the names of the variables here if you've already listed them up above. I could just say group by variable 1 and variable 2, and by position, it will reference these two up here. So this will give me the same results as I had before. And again, I love this because then like I could copy paste this and replace unit concept ID with measurement type concept ID. I don't know why I would do this necessarily, but, and then I could just run it again, right? Like it's like ready to go. It's a super nice template for any kinds of investigations you wanted to do. The concept names are not correct. So this should be measurement type concept ID as well. Okay, so hopefully that was also accidentally a demonstration that you can put multiple queries in the same workspace. You just have to put a semicolon after them to split them. Otherwise, it will yell at you. Says,
And if you
I thought we were done.
If you highlight them, it'll only run that query and you hit run. But then if you don't highlight them and you just hit run, it'll actually run both of them and it'll give you separate results, and you can go in and so you can actually run multiple queries at the same time.
Yeah. So I ran both of those at the same time because I didn't specify. So now I can go in and look at each of the results separately. So you can choose whether you like to have it across multiple tabs or down a single tab in BigQuery. Okay, I kind of jumped ahead in our investigation a little bit here, the sneak peek of where we're going with this. But if we go back to just looking at our unit concept IDs, there's also a keyboard shortcut. You can do like Option E or Windows E. Windows E or Command E will run whatever you have selected or the full thing. That's what if you can't see me click run, that's what I've been doing. I forgot I used that. Okay, so here we have found our problem that was reported to us. We have replicated it. You'd be surprised how many times someone tells you something's wrong and then you're like, that's not really what's happening. Thanks, Ayer. And so from here, we say, okay, what is going on with these that they don't have any information for them? So I'm actually now going to look at a subset of the data. So rather than doing these aggregations across the full data, I'm going to say, I still want that, but I actually want, I'm going to look at everything in the measurement table for now because I'm kind of in exploratory stage, and I'm going to say where measurement concept ID equals that and unit concept ID is null. So what I want to say is like what's going on in those cases that we see here where this unit concept ID is null. Let me just look at the data there and see what's going on. Let me put a limit on this just so it doesn't take too long. Okay, so here we can scan across our data and take a look and see. So a few things that I'm noticing. Anyway, well, let's see. It's 2:49. We have a little bit of time. Does anyone notice anything surprising about this subset of the data where I've restricted it to the unit concept ID being null? Any observations?
There's a measurement time, but there's no values for the measurement at all.
Yes, absolutely. So the measurement values we would expect to be in value as number and or value as concept ID. The measurement source value actually is null in the DID light version because it contains free text. It's hard to say exactly what's in there. So this is null by design, but we would expect to have a result of a lab. And if we don't have a result, then it's not that surprising that we don't have units, right? Like that doesn't really, what would it mean to say, oh yes, it's milligrams per milliliter, whatever it is. So, okay, that is a good observation. Anything else here? I guess, so something else that I noticed when I was looking at this, but you have to have looked at the overall, maybe we can preview, measurement, preview. Okay, so I'm gonna speed up the process by saying, if you look at the measurement type concept ID here in the preview, you'll notice that it's a lot of these 44 billion numbers here, right? Like that's the most common one. And so we can actually like check what this means, because measurement type concept ID is like, I don't have any sense of what kind of information would be in there just from reading that name. So I'm going to go look in Athena and see what this is. I could also look in the concept table, but since it's only one, it's easier for me to put it in Athena. Okay, that means lab result. That seems very reasonable, but not very helpful. If I go back and look at this table where I've subset to the null results, the measurement type concept ID is different here. And we haven't done anything conclusive to say that it's always this in most cases and always this in the other cases, but it looks different. And so I think it's worth, for me, it would be worth checking what this one means. And if we go to Athena, that was not helpful. So this was a concept ID. Here we go. I have to go down to find the concept ID. So this one means test ordered through EHR. It doesn't mean lab result. Yeah, so, and it's interesting that it's even in here because it's non-standard. I didn't notice that before. I wonder why this is in the table. So say that it's a lab ordered. These ones say that it's a lab result. So my hypothesis upon seeing that is going to be maybe the ones that say lab ordered don't have results. Maybe the ones that say lab results have lab results. So to design a query around that, right, I want to confirm that. Like that's what it looks like from just looking at the subset of data, but I don't know for sure that that's what's happening until I look across all the data. So I need to do another aggregation here. So I'm going to copy what I had above because this is my basic template. And I'm going to say, let's add another variable in here of measurement type concept ID. And so now it's going to like do cross tab counts across all of these things for me. Cool. Okay, so this looks pretty incriminating. When the measurement type concept ID is 5001, which means ordered lab, then there is no unit concept ID. And then the rest of the time there usually is. Two cases where there isn't is like, yeah, data's messy, that's okay. But that looks very different to me than this one where it's always null. And I think if we also include the, if we restrict to the measurement, what do I want this to be? Like something like this, checking the value observation as well, because remember we noticed that the value wasn't filled out for these, then there's like an interaction there as well. So I'm expecting again that when the value is missing, yeah, so most of these fall under this final category. So this is the kind of process, I'm going to start to wrap things up. This is the kind of process that I would go through to try to figure out what is happening in the data and make sure that my understanding is correct. So I'm going to rely on a lot of the functionality in BigQuery to be able to sort of poke around, try different kinds of queries, look through the tables, look at the preview and see what's going on. And honestly, the kinds of queries that I run most often are frequency counts. So using the count and the proportion is my advice. And then things like this, like just look at the data that looks suspicious. One other thing that can be useful is to try to look at a particular person's medical history which I didn't show today, but I have it in some of the examples that I'll send out after the workshop. So basically just taking the data and manipulating it using BigQuery to get it into different formats that actually mean something to you as a human, because the data in its raw form is not going to mean anything. So yeah, that is the sort of example of sort of just working through these different tables, using all of the features and trying to learn something about our data, relying on those different tools. So I'm going to wrap up the content here. We have a few other examples. So other ways you can interact with BigQuery besides the console or the command line include Jupyter notebooks, which is something that we do here a lot on the data science teams. And there's a lot of really good tutorials that we have on working with STARR-OMOP using Jupyter notebooks. So I definitely recommend those. And they're also really nice for preserving a trail of your queries and sharing or replicating your data, because you can save it as a notebook and have different comments and sections and things like that. It's a little easier to share than a BigQuery console, set of queries. You also can connect to BigQuery from R. So if you're really familiar with R, you might want to try to go that route, but we don't have as much support and tutorials for that. We typically use Jupyter notebooks on our team. There's lots of other resources. There's the Stanford STAR YouTube channel, which is open to everyone. And there's 4 tutorials. They're very extensive. I think a lot of folks here haven't done them because you weren't already part of the training project in the last few days when we went through and added you all. Tutorial 2, I believe, is a lot of similar content to what we just did today, but it's in Jupyter notebooks. So that might be a good place to go if you want some review or some more in-depth examples of running queries on STARR-OMOP. And then there are also Jupyter notebooks, which you can access directly upon request, and STARR-OMOP office hours and the Slack workspace. If you want to be added to those, there's actually instructions in the tutorials, I believe, for how to be added to those. So that's where I would recommend everyone start, but you can also email Priya at prd@stanford.edu and she can get you set up with all of that.
Yeah, so basically if you request access to the tutorials, you're automatically given access to the code.stanford.edu, which is just a GitLab with sample code for you to get started. You will automatically get access to this training project, which you now already do. You'll be added to the Slack channel. So all of those things sort of happen automatically. They also happen if you just ask for STARR-OMOP DID access. But yeah. But we really want you all to use this data as much as possible. The whole goal of making this available pre-IRB was that you could really explore this data on your own, and we were trying to remove the barrier that an IRB causes. But then, I think big thanks to Natasha for actually this workshop, because we used to hold these tutorials in person before the pandemic hit, and then we just recorded them and they're on YouTube. And I think having live workshops is actually really nice. So what I will do is, for all of you who attended it, in the next day or so, we will be sending out a feedback form. So it'll be really great if you can respond. Let us know if this is something you found useful, if this is something we should continue, because we really want people to use the STARR-OMOP data.
Yeah, definitely. And also shout out to Georgia, who I think is still here, for it was discussions between the two of us when we were working through some of her questions on STARR-OMOP that really inspired the workshop. And it was like, oh, there's a lot of cool stuff here that people should be aware of and hopefully use more. So thank you, Georgia, for those interesting conversations. And yeah, I would love feedback on this. Like Priya said, this is the first time we're doing this workshop, first time I'm doing any workshops. And so would love feedback on like pacing and content and all of that stuff. You can reach out to me directly on Slack if you're comfortable, or you can fill out the feedback form and be anonymous if you'd like, or not anonymous.
So Natasha, you had a question about the R. So I think there are a couple of R notebooks also in that GitLab. But in general, almost all the Odyssey tools, the Odyssey tool stack primarily uses R. And what I am trying to do we're going to try to do in parallel, and if there are others, some of you who want to be involved in this effort, is really now that Nero or Karina is back up and running, really trying to get that cool tool, the Odyssey tool stack, so all the analytics packages to work with the STARR-OMOP DID data, so actually try to run already existing cohort diagnostics and maybe old network studies and so on. But I mean, to be really honest, Natasha, our issue is like we are just only so many people, and there are just only so many things you can do. So you want to help us, we'll give you the resources, we'll support you as and when we can. But like, you want to push through, that'll be great.
Did you say Nero is working again now?
Yes. So I don't know how long you've been here, but you may remember that Nero on-prem had gone down. Had gone down. So they have a replacement. It's called Karina. So Nero on GCP was always there, but like people don't want to use GCP. You wanted to use the on-prem version. So they do have I think it's still in beta. I don't know if they've rolled it out officially, but you can, if you email SRCC and ask them about Karina, I'm going to just type it up here. It's CARINA.
But otherwise, when you're talking about, otherwise when you're talking about Jupyter and R, are people just like running those locally, or how are people doing that mostly?
So you can run it, you run it locally on your own machine. You can, so the notebooks live in your own machine, but you do need an environment. The environment is not your local environment, but the environment needs to be Nero.
I know there's like steps to connect to Google BigQuery, right? Okay.
Yeah, so you can't access STARR-OMOP DID without being in a GCP environment.
Right. Okay.
So when you set up your environment, even whether you're in Python or R, you set your os.environment to this GCP environment.
Okay.
Great. Well, thanks so much, everybody, for joining. And we'd love to hear your feedback. Hope you enjoy the rest of your day. And if you do have questions, we'll stick around for just a few minutes here. We can wrap things up in general.
Thanks, Natasha and Priya. That was great.
Oh, thank you. Thank you for coming, and thank you for inspiring this workshop, Georgia.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.